Okay, so welcome back to the office. We're going to move on now from basic computational methods to more advanced computational methods. And as outlined in the previous video, things can get a little bit complicated here, but try to stick with it and go through all the steps and processes necessary to learn how to do this properly, because we're going to be using this statistical method to calculate volatility throughout the video series, because we actually use this method to learn a lot more than just about volatility. We learn to use it to interpret and get historical perspective from the data. Now, I've got with me Christopher Quill, who's the Institute's statistics analyst, and Chris is now going to take you through the whole process. And as I said, again, please just practice this because it becomes very, very important throughout the video series to make sure you've got this process absolutely nailed. So take it away, Chris.
In this Excel example, we're going to assess the daily volatility of two currency pairs, the Aussie dollar US dollar and the Euro US dollar. We're going to analyze what's called a distribution of returns, and the outcome will be that we're able to get a really good understanding of how these assets behave and the opportunities and risks associated with trading them. So what you'll need to do is have a new Excel sheet open like I have here and save it as something sensible like FX returns distributions, and remember to keep saving as you go along to prevent any loss of work. So the first stage in the process is to actually obtain the data. So we're going to look at the Aussie dollar US dollar first, and a website that you can actually obtain daily historical prices from is investing.com/currencies. And then this has basically historical data on almost any currency pair you want. But we're going to look at the Aussie dollar US dollar, which is here. So if you click on that, it takes you to a summary page for that asset. We're going to go to historical data, and we want to look at daily periods, as I discussed earlier. And with the time horizon we're going to look at is from 2008, so 1st of October 2008, until March 2015. So the 1st of March 2015. So you select those two dates there and click apply. And then that gives you all the daily price data within that time horizon that we selected throughout the page. Now there's no quick and easy way to extract this data into Excel, or not in terms of downloading it straight to Excel. So we have to use a rather crude method, and that is just scrolling to the bottom of the web page, so where the data sort of begins from 2008, and manually kind of clicking and dragging over it to select it, and then select all the data up until the top, and including the column titles. So the quick way to do that is, as I've done there, select a few at the bottom and then scroll to the top of the web page and then hold shift and left click before date, and that will select everything up until then. Then what you need to do is copy that data, so press Control C, copy that data and paste it into Excel with Control V into cell A1, and you'll see that all the prices are imported as they were with separate columns on the web page. The next thing we can do, just to tidy up a bit, is just change the column width so that we could see the date properly and the percentage change. So to do that, all you do in Excel is go to the intervals between the column sort of headings and click and drag the column width. To understand volatility in asset prices, we need to analyze their returns. So the next step is actually to calculate some daily returns using the data that we've got. So we're going to calculate daily returns in two ways. One is the open to open percentage. So in column G, I'm going to head that open to open percent and adjust the column width appropriately. And then in column H, we're going to look at high to low returns as well. High to low percentage returns. So what we're going to do here is essentially just calculate the return from one day to the next using the opening prices, and high to low calculate the returns of sort of investing at the low and closing at the high of each day. So to do that, for the open to open returns in cell G2, we do our first returns calculation, and we say equals to open brackets open of today minus the open of yesterday divided by the open of yesterday, and that will give us a percentage return there. So you can see in Excel that it uses cell references, so that would be today, or the first day that you're looking at, C2 minus C3, which is the day before, divided by C3, which is the day before, which gives you a percentage return from February the 27th in this case to March the 1st. And to quickly and easily sort of copy that down for all the cells in the column, we just double click this sort of black box once it's highlighted in this cell. Double click this black box in the bottom right, and that will copy it down as far as the rest of the data goes. And if we scroll down to the bottom of the sheet, you can see it goes to the end of the data. The only error that we have here is in the final cell, which is a div0 error. And the reason why there's an error there is because it's trying to reference data from the day before that we don't actually have. So it's trying to go before October 1st, and we don't have data for that. So we can just select that cell and press delete to get rid of that. Next, we move on to high to low returns, calculated in a very similar way. This time we use the high and the low of the same day. So we're taking the high minus the low as a percentage of the low, so divided by the low, and that gives us a percentage return if we were to invest at the low and close at the high each day. And the open is investing at the previous open, closing at sort of the current open, and looking at that historically. So now we've got our returns for high to low and open to open, so two sets of daily returns. If we select those two columns, so click and drag over G and H to select them both, and then right click within the selection and go to format cells, we can format them as a percentage to 2 decimal places, or we use 3 decimal places there, and that just makes the returns values a bit easier to understand and a bit tidier as well. With each set of returns data, we're going to create a frequency table and a histogram plot. So these are essentially going to show us the frequency of returns landing in different ranges. For example, the number of open to open daily returns that land between -1% and 0% in the data set that we're analyzing. So first of all, we're going to define some ranges using intervals. And obviously different assets have different volatilities, and so the ranges created do require some discretion. However, a good place to start is looking at returns in roughly 20 ranges between, say, -3% and +3%. To define those ranges, the intervals that we start at are at -3%, and we increase incrementally by 0.3% up to +3%. So we're going to do that now in column J. So I'm going to head the column intervals, and then underneath that start at -0.03, which is -3%, and then in the next cell down will be -0.27 for -2.7%, and then if we click and drag over those two cells that we've just entered there, and then drag the black box down, so copy this down, we can copy this down however many cells it requires to go up to 0.03 there, so that's +3%, and it's going to use the same interval as was used in the first two that we dragged down, so that's 0.3% for each one. So those are our intervals that are going to define the ranges that we analyze our data with. So now we can create a frequency table to show the number of returns that lie within these ranges. The easiest way to do this is using the data analysis tool within the data tab. So if we click on the data tab up here, and then go to data analysis here, we'll be able to move on to the next stage and create this frequency table. However, some of you may not have data analysis already installed as an add-in within Excel. So what you'd need to do is go to File and then Options, Add-ins, and then press Go, and you'll need to make sure that the Analysis Toolpack add-ins are checked, and then press OK, and you should see this data analysis function here just pop up. So let's continue by using that. So if we click on data analysis, we're going to select the histogram analysis tool, click OK. So the input range for our histogram is going to be the actual data that we're analyzing. We're going to analyze all the open to open returns first before we move on to high to low. So we need to select the input range, which is all the open to open returns in our data set. So that's from cell G2 down to the end of the sheet. So the quick way to go to the end of the sheet from here, after you've selected G2, is holding Control Shift and then pressing the down arrow on the keyboard, and that will automatically select all the cells down to the point where there's a gap. So that's down to 1996 there. So then if we scroll back up to the top of the spreadsheet, we can put in our bin range. Our bin range is just the intervals that are going to be used to sort of define the ranges. So we've created that here, that's why we did that. So if we just select from J2 to J22 there, and then we want to select the output range for our frequency table. You need to be a bit careful here, because once you click output range, select output range as the option, it will automatically kind of move the cursor back to the input range for some reason. You need to make sure you click back within the output range box and then select cell K1, so we put it next to our intervals here. And then we just click OK, and that gives us our frequency table data. So you'll see that the bin values are the same as the intervals, so that's why we define them there, and they're going to sort of define our ranges, and we'll go on to naming those properly in a few moments. And then we've also got a frequency count next to all of these intervals. So what this actually means is it's telling us, this frequency table is telling us the number of data points or returns that lie within the ranges that the intervals have defined. So for example, if we look at the first one, we can say that there's 10 days when the returns are less than -3%, so minus 0.03 in the interval range here. When analyzing, our open to open data. So how it sort of works is the first number here is actually the number that's less than the first interval. The next number is between the first two intervals. So there's 8 occurrences, daily returns, open to open returns between -3% and -2.7%, and so on. That goes all the way up until you get to greater than 3% when there's 12 occurrences. So from here, what we can do is plot a histogram from this frequency table, and that's essentially just a column chart. So if we select from cell K2 down to L23, so this range here, so the intervals and the frequency, and then go to Insert, Column Chart, and just choose the first one there. This gives us a histogram or column chart of all our data. So before we go any further and I talk about this, I just want to tidy this up a little bit. So we don't need this series 1 label here, so if you click on that and press delete, that will get rid of that. What we'll also do is give the chart a title. So if you go to Chart Tools, with the chart selected, go to Chart Tools, Layout, then Chart Title above Chart. We can put in a title here by selecting that chart title there, and we're going to name it Open to Open Returns. And then we'll have we'll label the y-axis and the x-axis. So to do that, you go to Axis Titles, we'll label the vertical axis, so the y-axis, rotated title, and this is just going to be frequency, and then the x-axis, so the horizontal axis below, we'll do range or returns range. We'll do returns ranges. So that sort of explains the data a bit more that we've got there. And I think actually before we go on to any more, we'll kind of tidy this up a bit further, because at the moment it's not very clear as to what our ranges actually are, because we're just using intervals at the moment. So what we want to do is put in, so name in column M, we'll put text labels. So that's going to be text labels for to identify the ranges, and we'll change this x-axis here from looking at the sort of interval numbers to actual text, proper text labels for the ranges. So what we can do here is first of all select all the cells that are going to become text labels for our ranges. So that's M2 to M23, and then right click within that selection, format these cells as text and press OK. And then we can start just going ahead and manually labeling these ranges. So the first one will be less than -3%, and 10 occurrences happen there. And then as we continue, the next range would be -3% to -2.7%, and then -2.7% to -2.4%, -2.4% to -2.1%, and so on. We just keep going through the whole frequency table like that. So next -2.1% to -1.8%. And you'll notice at this stage probably as well that as we go through naming these ranges, more and more occurrences are happening as we sort of tend towards zero, or the mean of the data we're looking at, and we'll get onto that a lot more later. It's a little bit of a tedious process this, but it's necessary just to make things clear on the histogram so we know exactly what we're looking at. You might be wondering at this stage why we have so many intervals. Well, the reason is so that the chart, the histogram, is easier to interpret. So we actually get an idea of smaller ranges, what the occurrences that happen in smaller ranges. Obviously, this task would be easier with less intervals, but we're more concerned with how we interpret the data at this stage. So almost done here. So the final range that we look at here is more than 3%, so greater than 3%. And that's all our text labels done for our ranges that we're looking at. So let's just adjust the column width there so it looks a bit neater, and the purpose of that was to put it into the graph. So if you right click on the graph and then go to select data, then we edit the horizontal axis labels. Click on edit there. At the moment it's looking at the bin range, so that's just the intervals. So we're just going to move that across to M. So we want to look at, if we click in that range there and go from M to, change the other K to M as well, M23, that will select all the text labels that we've just created there. And now our histogram is a bit easier to kind of visually interpret. So now we can see, the distribution there between different ranges of returns. So basically what we've got here is a distribution of returns that we're analyzing across different ranges, as we've discussed. And you can see that much more of the data generally lies near the middle of the chart than in the tails, again, as you might expect. And this sort of rough shape here is a typical example of what statisticians call a normal distribution. A normal distribution is a bell-shaped frequency curve like we have here, and is one of the most common occurring probability distributions that can be seen in many different areas of life. A typical example often used is actually human height. So you'd have here human height instead of frequency here, as we've got, and then human height instead of percentage returns, and we'd split them into ranges as well, and you sort of get a perfect kind of bell-shaped normal distribution from that. So a perfect normal distribution is actually kind of symmetrical around the mean, and it has defined frequency percentages in different portions of the distribution, which we'll come on to a bit later. And we'll also look at how our distribution here is a little bit different from the perfect normal distribution. Before we move on to any of that, I'm going to show you how you can quickly obtain some summary statistics for the open-to-open dataset that we're looking at. So I'm just going to move this histogram to the side for a moment, and we're going to use the data analysis tool again. So if we go to data on the ribbon and then click on data analysis, what we can do is go to an analysis tool called descriptive statistics there, click on that and then click OK. And the input range that we're going to use is the open to open daily returns again, because we're still analyzing those daily returns as opposed to high to low. And the input range is going to be similar for the histogram data, or similar to the histogram data. So that's going to be from cell G2 to G1996. Then you scroll to the top of the spreadsheet again, and we want to set the output range to this time Q1. Again, be careful to reselect the output range since it sort of automatically puts you back in input range. And then just check the box that says summary statistics, and then that will give us, when we press OK, a bunch of summary statistics for our open to open data set. And before we kind of look through that in any detail, let's just change some of these to percentages so that we can look at them a bit more closely. So mean, standard error, so mean down to sample variance, if you select all of those and format those as percentages to let's say 3 decimal places, and then we'll do the range maximum and minimum also as percentages to 3 decimal places, and kurtosis, skew and sum just as numbers to 2 decimal places. Okay, so let's go through and look at what these statistics actually mean, interpret them a bit more closely. So the mean is the average open to open daily return for the Aussie dollar, US dollar over the period that we've analysed. The median here is the middle number of the data set when we arrange it in numerical order. So if we have a set of numbers that is 1, 2, 3, 4, 5, the median is 3 because it's the middle number when it's listed in numerical order. The standard deviation is a measure of dispersion or volatility in the data. So this is a key statistic that we'll consider in terms of opportunity and risk when trading an asset. Kurtosis, that's basically a measure of how peaked the data is around the mean. so in the middle of the data set, and how large the tails are, so the extremities as well, when you compare it to a normal, a perfect normal distribution. So any number greater than 0 in Excel for the kurtosis value basically means that the data set you're looking at is peakier and has fatter tails. What that means is if it's got higher peaks, so more frequent occurrences by the mean, and also more in the extremities, obviously it has to sacrifice some data in the sort of middle sections, or the left and right middle sections of the distribution. So there's less occurrences sort of around here and here to a normal distribution, but more in the middle and at the ends to make up for it. So the skew next. So a negative skew basically means that the negative tails or extremities are larger than the positive ones, and vice versa. The range is simply the difference between the highest daily return in the data to the lowest. The minimum is the lowest daily return, and the maximum is the highest daily return. The sum is a bit irrelevant. That's just the sum of all the open to open returns in our data set. It doesn't equate to the return that you would get if you held the position the whole time. Just make sure you're aware of that. And the count is the number of periods analyzed in our data set. So in this case, 1,995 days. So let's return now to our frequency table, where we can sort of translate our frequency counts into probabilities. So in column N, I'm going to head it probabilities, and column O, cumulative probabilities. Adjust those column widths appropriately, and then all we're going to do is basically in the probabilities column calculate the frequency within that range as a percentage of the total count, the total frequency in the entire data set. So this formula would just be, so cell L2 10 divided by cell R15, which is the total count. Now what we want to do is be able to quickly calculate this for the whole column. So in order to do that, if we fix the reference to the total count, but not the sort of frequency count for each range, when we copy it down, the reference here doesn't move for the total count, but these do. So we'll get percentages for all of them quite quickly. Now, in order to fix the reference, you can press F4 while sort of with the cursor in the R15 bit of the equation, the formula, and that adds a dollar sign before the R and before the 15, and that basically means it fixes the column R and the row 15, so that cell. And then we press enter and copy down, and that's a really quick and easy way to sort of calculate all those probabilities. If we right click within that selection and change it to format cells, change to percentages to 2 decimal places, then we can sort of more easily interpret that. And then cumulative probabilities, we're just going to work out the cumulative probability from sort of -3% upwards. So the first range is less than -3%, and it's obviously going to be 0.5% as we have there. So I just put this cumulative probability equal to this probability here. The next one will be the sum of these two, so the sum of the first two ranges, so less than -3% and also -3 to -2.7%. So again, a good way to arrange this formula so we can copy the rest down, copy it down in the rest of the cells, is just do this current probability for the range in that row plus the previous cumulative probability. By doing that, you can then copy down, and what you do is you end up with a cumulative probability assessment, which obviously ends up in analyzing 100% of the data. So why have we sort of looked at the probabilities here? It makes it a lot easier to kind of interpret what we're doing, to actually come up with some valuable information rather than just looking at frequency numbers where it doesn't really mean anything unless you know the total count. and I suppose you can get an idea of what they're like compared to each other, but probabilities is something that everyone understands. It makes it easier to kind of analyze. So what you can sort of start saying to yourself by having these probability columns is, for example, quite simply in the probabilities column, you could say between minus 0.6% and minus 0.9%, 6.3% of occurrences land within that range. So you could say, based on historical data, there's a 6.32% chance of this asset on a daily basis using open to open returns landing between minus 6% and minus 9%. Sorry, minus 0.6% and minus 0.9%. As for the cumulative probabilities, what you could do is, for example, if you're interested in how often the asset loses more than, say, minus 1.5%, you could just take the cumulative number for less than minus 0.5%, which would be here. This is 3.81% of the times this asset loses 1.5% or more. Equally, how much does it ever gain more than roughly a percent? Well, you just do, it's roughly 95% of the times it doesn't gain a percent, so that means 5% of the time you might get more than a percent day trading this Aussie dollar versus US dollar from the open to the open. Now we're going to do a bit more in-depth analysis of our data, and we're going to find out information such as the average positive and average negative returns, and the number of days the asset, so the Aussie dollar, US dollar, is up or down. And to do that, we're going to need to clear some space to work with at the top of the spreadsheet. So I want to create about 10 blank rows at the top. So to do that, I'm going to select from row 1 to 10 on the left-hand side here, click and drag to select all of that, and then right click within the selection and press insert. And then you'll see that you've got 10 new rows there inserted, and all our previous data has moved down. So what we're essentially going to do here is continue dealing with our open to open returns data, daily data, and like I said before, we're going to work out information such as the average positive and average negative returns and things like that. And what we're going to do is create a formula that is like an average formula that's variable dependent on how we filter our raw data here. So before we move on to that, I just want to show you how we actually filter stuff here. So this raw data here is now from cell A11 across to column H and all the way down. And what you want to do to add a filter to this data is just click any one of the column titles, and then within the ribbon at the top, make sure data is selected and go to filter. Just select that and it will give you some drop down arrows in all the column titles. And when you click on one of those, there'll be various options to sort or filter the data. And like I said, we're going to be using the open to open data still. So one of the things that we're going to be doing is filtering for positive open to open data. So in that scenario, we go to number filters, greater than, and then in this box here put is greater than 0. And that will then filter all of our open to open daily returns for only positive values. And what you may have noticed is that some of the data that we calculated previously, our frequency table, our descriptive statistics, and our graph or chart, sorry, has sort of been squeezed together a bit there, and it looks a bit strange. So the reason why it's done that is because we've added this filter here, and we filtered out all the negative or flat rows in our data set. So don't worry, all you do when you clear the filter here, click on the drop down arrow and then select clear filter from open to open, it restores all the rows and you'll see that you've still got all the data that we worked with previously. So just to make sure there's some clarity here when we continue working out some new statistics, I'm just going to put in another open to open heading here. So from cell I1 to I4, I've selected all those cells. I'm going to go to Home tab on the ribbon and then select Merge and Center, Wrap Text, and then the sort of center text alignment there. And then within this cell, which is now a sort of much larger merge cell, type Open to Open Data, just so we continue knowing what we're working with. Now, as I said, what I'm going to do is sort of calculate an average, use an average formula that changes dependent on our filtered data. And we're going to do the same for a count as well. So the number of occurrences that are positive or negative in our data set. So to do that in cell J1, let's start with the averages. So we'll have average returns and adjust the column width appropriately. And within that, we're going to calculate the average return based on the raw data here, whether it's filtered or not. So the formula for that is equals subtotal, open brackets 1 for the average, that's the function number for average, comma, and then reference all our data. So that's now from cell G12 down to the bottom. So remember, the quick way to get down to the bottom of that data set is Control Shift and down, the down arrow key. And then close the brackets, press enter, and you'll see that we've got an average returns figure there. If I just format that cell to show itself as a percentage 3 decimal places, you'll see that that's exactly the same as our average value, our mean value in our descriptor statistics, which we calculated earlier, which is as you'd expect, because at the moment all our raw data here is unfiltered. Now when we filter it, this cell will change, and the descriptor statistics here, they'll stay the same because they're calculated, they're sort of hard coded in from all the raw data that we analyzed before. So bearing that in mind, let's now name another couple of cells. We want to calculate the average positive return. So shorthand, I'm going to use avposret, and the same here for negative returns. And then in N1 and N2 next to those cells, we're going to actually put in the calculations. So let's proceed by filtering the open to open data, going to number filters greater than 0, so we only have positive data in the open to open column. You'll see that there again, we've only got positive open to open data. You'll also note that our average returns formula has now spat out 0.576%, and that is our average positive return. And what we can do is, if we select that cell K1 and then press Ctrl C, copy it in some way, and then we can paste it into N1 for average positive return. So we right click within that cell, and then we want to paste it as a value, as values, which is this clipboard sign here with the 1, 2, 3 on it. And that means that that's basically now hard coded into that cell, and it won't be variable dependent on the how we use the filter. So next we're going to change the filter for negative returns. So we go to less than this time, 0. And the same way we copy that cell into N1, N2 this time for average negative returns as values. And that's our average negative return value. So if I just select those two and format them as a percentage again to 2 decimal places. There's 2 things to note quickly here before we move on. One is that they're both very close in absolute terms, and what I mean by that is that their magnitude either side of 0, both positive and negative, is very similar, and so they're fairly symmetrical, which makes a lot of sense because our histogram, if we unfilter our data again here so we can see the histogram better, is pretty symmetrical. So we would expect the average positive and average negative returns to be roughly equal either side of 0. And the other thing to note is that they're both very small return values, only 0.5% in a day for an average positive or an average negative, basically. So let's move on now. We're going to look at the count, which is basically the number of occurrences that occur on positive days and negative days. So we're going to count all the days that are positive and negative and 0. So to do that, we're going to use a slightly different formula, but roughly the same. So in cell J2, I'm going to type count, and K2 will be roughly the same formula as before, subtotal, open brackets, this time 2, not 1, because 2 is the function number for count, comma, and then the same references as before, so all are open to open data. And you'll see that the count is 1,995 days. That's fine, that's in line with our descriptive statistics as we would expect because the data is unfiltered at the moment. So moving on to sort of column P here, so P1 we're going to put pos count and neg count, so positive count and negative count, and then Q1 and 2 will actually paste the values into those cells. So let's change the open to open returns, filter them for greater than 0, so we'll do the positive count first. And you'll see that our filter dependent count cell here has now changed to 988 days. So we can copy that and paste it as a value as we did before into the positive count cell. And we'll do the same for negative count as well. And that's 986 days. Paste as a value. Let's clear the filter on the open to open returns. And the other thing that we should just calculate for thoroughness is the 0 count. So the 0 count is just going to be the total count minus the positive count minus the negative count, which is 21. So that's all the days left over. So all the days of 0 returns. To make this a little bit more understandable, we're going to put it in percentages as a percent of the total count. So we want to know the percentage of days that are positive and the percentage of days that are negative in our data set and the percentage days that are 0. So to do that, in cell R1, we're going to just type equals the positive count divided by the total count. And if we fix the total count cell reference, so if I press F4 around the R25 cell reference, it will add the dollar sign which fixes the dollar signs which fix the row and the column, so that that reference doesn't move when we copy this formula down, but this cell reference will move down, and that will calculate all our percentage returns slightly more easily. Let's format that as a percentage. So we can see there that 49.52% of days in our historical data set are positive. So the Aussie dollar is getting stronger versus the US dollar, so the price is going up. And the opposite for negatives, that's 49.42%. So slightly less, but very, very much similar, very symmetrical kind of data in that sense. And then the 0 count is roughly 1.05%. From that, what we can do is calculate some probability adjusted average positive and negative returns. What that basically means is we could adjust our positive and negative returns that we calculated here based on the frequency in which positive and negative returns actually occur within the whole data set. And the numbers that we're left over with are basically numbers that tell us, for example, with the probability adjusted average positive return, it will tell us the average daily return that we would obtain in the period, in the whole sort of historical period that we've analysed, if we only invested on days when the asset was up or positive and we weren't participating on the other days. So let's do that now. Shorthand, I'm just going to write ADJ for adjusted average positive return, and then similar for the negative one. And the calculation is simply going to be for the average probability adjusted average positive return, it's going to be the average positive return that we calculated earlier times by the positive count as a percentage, and the same for the negative probability adjusted average negative return as well. You can see I could drag that down there because these cells, it just uses the references below, which are the negative numbers anyway. So let's format those cells to percentages with much less decimal places. So 2, for example. Close that column up a little bit. So one thing to briefly note here is that, again, these numbers are very small, and it basically highlights that your day trading opportunities here are very kind of small, even if you get it exactly right. You know, there's not that much volatility in this asset that we're looking at, in the Aussie dollar US dollar, and so day trading opportunities are minimal. So now let's move on to looking at standard deviations and some more volatility analysis. So essentially what we're going to do is, a little bit like we did earlier with the frequency table, define some intervals that create ranges that we're then going to see how many daily returns lie within those ranges that are defined. And they'll be defined by 1, 2, and 3 standard deviations from the mean. So we're going to create a table for that to define the intervals, and then we'll do a count as well. So this is all about understanding how much data is accounted for by these 1, 2, and 3 standard deviations from the mean. And remember that standard deviation is our level of dispersion or volatility. So the more standard deviations either side of the mean that we look at, the more data that we're going to account for. So we're going to create a table now called standard deviation, STDDV for short, and then that's in cell W1, and in cell X1, Y1, and Z1, we're going to have 1, 2, and 3 for 1, 2, and 3 standard deviations from the mean, and we're going to create upper and lower bounds for those figures, 1, 2, and 3 standard deviations from the mean. So to calculate the upper bound for one standard deviation from the mean, all it is the mean plus 1 times the standard deviation figure. So in cell X2, all we're going to do is put equal to the mean, which we calculate in the descriptive statistics, plus 1 times the standard deviation figure, which is also in the descriptive statistics that we calculated earlier. And then for 2 standard deviations above the mean, it's the mean, very similar, plus 2 times the standard deviation figure. And for 3 standard deviations, it's the mean plus 3 times the standard deviation figure. And very similarly for the lower bounds, it's just simply the mean minus 1 times the standard deviation figure for the 1 standard deviation lower bound. The mean minus 2 times the standard deviation figure for 2 standard deviation lower bound, and the mean minus 3 times the standard deviation figure for the lower bound of 3 standard deviations from the mean. And these basically define our intervals that help us calculate how many returns lie within these ranges. So we're going to look between these two values for 1 standard deviation from the mean, see how many daily returns lie within those 2 bounds. The same for 2 standard deviations and 3 standard deviations from the mean. And then what we're going to do is take note and record those values in another table, another standard deviation table. So in cell AB1, I'm going to head this table standard dev 2, and then put 1, 2, and 3 standard deviations in the column going down. And what we want to do is calculate the actual number of occurrences that lie within those bounds. We want to convert that to a frequency percentage, so the actual number of occurrences within those bounds as a percentage of the total number of occurrences, or the count. And then we want to be able to compare it to a normal distribution. So we want a normal count and a normal frequency percentage. So let's go ahead and calculate the actual count numbers that lie within these ranges, 1, 2, and 3 standard deviations from the mean. And all we're going to do that is filter these open to open daily returns for between those numbers. So we're looking at greater than or equal to the 1 standard deviation below the mean, which is minus 0.00873, and is less than or equal to the upper 1 standard deviation from the mean value, which is 0.008792. Once we filter all our open to open daily returns for that, our count box that we made earlier, our count formula, will adjust and tell us how many occurrences are within that range. We can just copy that figure and dump it in the new table, paste it as a value within the appropriate cell. So the actual count within 1 standard deviation from the mean. Let's go ahead and do 2 and 3 standard deviations from the mean now. So this time we go between minus 0.0175 to 0.017554, and now we have 1,890 days that lie within that range, so we can copy that cell again and paste it into the 2 standard deviations either side of the mean actual count figure there in that table. And finally the same with 3 standard deviations from the mean. So we're looking at minus 0.02626 to 0.026316, and the count that we have, the number of occurrences of days with the returns that lie between those values, is 1962 in that case. So paste that as a value, and that's all our actual counts that lie within those standard deviation bounds. We can quite easily convert that to a percentage frequency figure, as we did before, by comparing it to the total number of occurrences in our data set. So for 1 standard deviation either side of the mean, it will be this actual count figure here divided by the total count. And again, we can put an absolute reference around that cell reference, so that we can copy it down easily. So there we go, and let's format those cells to display themselves as a percentage to 2 decimal places. Now let's look at what a normal distribution would predict in terms of the frequency, percentage, and the actual count. So what we know from a normal distribution is that a perfect normal distribution accounts for, with 1 standard deviation from the mean, accounts for 68.2% of the data in the data set, and 2 standard deviations from the mean is 95.4% of the data points in the data set, and 3 standard deviations from the mean is 99.8% of the data points. And then we can kind of back out, reverse engineer the count figure from that just by taking the percentage figure for 1 standard deviation from the mean and times it by the total count in our data set. And again, we want to absolute reference the total count, so we can copy this down. And now we have some data in this table that we can sort of compare. So our empirical distribution, our empirical work here, versus what's predicted by a normal distribution. So let's sort of make some comments about that now, and sort of refer back to our histogram that we've got here. So what we can see is, with 1 standard deviation from the mean, we're basically looking at an upper bound of 0.9%-ish and a lower bound of minus 0.9%. So we're kind of looking at, from this column, minus 0.9 here, or here, to plus 0.9, which is here. So kind of this whole area here. And in our empirical distribution, that accounts for 80% roughly of the data, whereas a normal distribution would only predict 68%. So that then takes us back to our kurtosis value, which is higher than 0, which represents the peakiness in our distribution. So a kurtosis value of higher than 0 means that it's peakier around the mean than a normal distribution, which means more data lies within that range. So that's why in our empirical distribution you can see that 80% lies within a smaller area there in terms of ranges close to 0 than predicted by a normal distribution. As you go down to 2 and 3 standard deviations from the mean, that changes a little bit. So 2 standard deviations from the mean is roughly 1.7 plus 1.7% to minus 1.7%. So roughly from here to here. And in that case, we actually account for less this time than the normal distribution. So we've missed some data out here compared to a normal distribution, which means we must have more as a percentage in the tails after that. And then equally, that's the same thing that happens in the 3 standard deviations from the mean figure as well. In fact, it's slightly more prominent as well. We miss a bit more data. So what that is essentially saying is that our empirical distribution is peakier. It has much more data in a smaller ranges around the mean, misses out some in the middle on the way to the tails, but then has fatter tails towards the end. So there's more extremes, either side, positive and negative, than the normal distribution would predict, and also many more in around the mean as well. So the key bits to learn from this analysis that we've done so far is firstly that if you're trading this asset on a daily basis, the opportunities are generally very low. The empirical analysis that we've done here tells us that roughly 80% of the time the percentage returns day to day are between plus 0.87% and minus 0.87%. And if we take a look at our frequency table that we did earlier, we can look at some narrower ranges than that, look at minus 0.6 to plus 0.6% returns, and we can see that if we add these probabilities here, it accounts for roughly 66% of the data. And even if we go even narrower still, we can look at minus 0.3% to plus 0.3%, and it accounts for 44% of the daily returns that we've analyzed as well. So these are all very small margins to play with, and remember that we haven't even accounted for transaction or financing costs here either. The second key takeaway from what we've done is to recognize the difference between our empirical distribution and a standard normal distribution. So when you hear about volatility calculations for any asset, we typically talk about the standard deviation of an asset. And so if there was a standard deviation figure of say 0.8% roughly, like we have here, close to here, what's being said is that if the data was normally distributed, then there would be roughly a 68.2% probability of the periodic returns being 0.8% either side of the mean. However, our empirical analysis shows that the chances are actually much higher for a suppressed level of returns, as is shown by the peaky distribution around the mean here in our histogram. And equally, there's also more tail risk in the extreme movements. So put simply, when compared to a normal distribution, more often than not, the returns are suppressed by more than the standard deviation would suggest, and the tail risk events are higher than standard deviations would suggest as well. It's worth mentioning here why we're even comparing our empirical distributions to the normal distribution in the first place. So firstly, the basic shape of a normal distribution is very similar to our asset returns empirical distribution that we've got here. So it's a bell-shaped curve, and it's roughly the same shape. Secondly, the normal distribution is very easily defined, so this is quite an important one. The only information you need to define a normal probability distribution is the mean and the standard deviation, and you can then sort of determine the whole probability curve. So that's particularly useful because it makes risk or volatility assessment with the standard deviation figure much more comparable across assets. So if you simplify asset returns to a normal distribution, you don't need to consider differences in kurtosis or skew between assets, and you can concentrate purely on on the volatility and dispersion as dictated by standard deviation. So for those reasons, it's basically become very commonplace for both normal distributions to be assumed and standard deviations as volatility assessments to be used in the financial industry. Although standard deviations are the go-to risk measure and assuming asset returns are normally distributed is very useful, the analysis that we're doing here is to make you aware of subtle differences and increase your understanding of opportunity and risk when dealing with currency trading. Now we're going to move on to analysing the high to low returns. The first thing to note here is that structurally high to low returns can't be any less than 0%. So since we've assumed that we're investing at the low and then closing at the high, it's not possible. So because of that, the normal distribution analysis and the standard deviation analysis that we did in the open to open returns becomes a bit void because of the structure of the probability distribution. Equally, there's also no point in looking at average negative returns and statistics like that. So what we're going to concentrate more on is looking at the frequency table analysis, and we're going to take a look at the histogram to understand the differences in the probability distributions, and also take a quick look at the descriptive statistics. And once that's all explained, we can move on to analysing the difference between the Aussie dollar US dollar pair and the Euro US dollar pair with a series of statistics that we've already calculated here. So the first thing to do before we continue is just get rid of this filter from the open to open returns column. And then we need to plot our frequency table. So in cell J36, I'm going to head this column intervals again. And then we're going to look at intervals above 0 because, like I said, with high to low returns, you can't have yield returns of less than 0%. So we're going to start from 0.002, which is 0.2%, and go up in 0.2% intervals up to 4% max. And from those intervals, as before, we're going to create our frequency table data. So if we go to data on the ribbon and then data analysis, and then choose histogram here and press OK, we need to make sure that our input range goes from the high to low, uses the high to low data, so that's going to be H12, starting at H12 this time, all the way down to the bottom with Control Shift down on the keyboard, down to H2007, and then we're going to look at the bin range, which is the intervals. So that's from J37 to J56, and then the output range we're going to make K36, and then if we press OK, it will plot our frequency table there. So from that we can plot our histogram again. So we do that with that data selected, so just with the data, not the headings. We go to insert on the ribbon and then column chart, and you can see here already that our histogram, our probability distribution for high to low returns, is completely different in the way that it looks. It is not normally distributed at all. That's because of the structural fact that you can't have less than 0% returns, but obviously you can still have high volatility and a large tail in the positive side. So a huge difference between the high and low intraday is possible. So that's what creates this sort of lopsided distribution. So before we go any further, let's just label the chart and the axes. So this is high to low returns. So you do that just by clicking on the chart, going to Chart Tools, Layout, Chart Title, and then the same way, but this time axis titles, we'll label the horizontal axis first. That's going to be returns ranges, as in the chart above, and then the same for the vertical axis title. We'll name that frequency. So in this high to low example, I'm not actually going to go through and create all the text labels like I did before, just in the interest of saving time. What I'm going to do instead is just select the bin range that we've got there and format the cells to show themselves as a percentage to 2 decimal places, and at least that makes it slightly clearer on the histogram what's going on. And you can always refer back to the text labels here with how it works when it refers to the bin ranges, each of the text labels. So now let's move on to calculating the descriptive statistics. So we go to Data, Data Analysis, Descriptive Statistics, and we want to use the high to low data again in the input range. So that's from cell H12 down to cell H2007. We want the output range to be this cell Q36, and then make sure the summary statistics box is checked and just press OK there. So that's our descriptive statistics. And as before, we can change the format of all of these to percentages where necessary. So the mean to the sample variance and the range minimum maximum can all be percentages, and the others can be numbers to 2 decimal places. These are percentages to 3 decimal places to keep it consistent with above. Okay, so that's our descriptive statistics done, and from that, as before, we can calculate our probabilities and cumulative probabilities using the frequency table and knowing the total count from our descriptive statistics. So we'll head the next column there, probabilities, as above, and cumulative probabilities. And we work this out in exactly the same way. So we're looking at the frequency for this range of less than 0.2%, high to low returns, divided by the total count, so 80 divided by 1996. We're going to fix that cell reference R50 with dollar signs so we can copy it down easily, and then format all of those cells by right-clicking within the selection, formatting cells as a percentage to 2 decimal places. Then we go to cumulative probabilities, work this out in the same way as we did before. So the opening cumulative probability is just going to be the same as the opening range probability, so the opening range being less than 0.2%. And then from there we're going to cumulatively add up all the probabilities until you get to 100% of the data accounted for. And we do that by looking at the relevant probability for the range in that row and adding it to the previous cumulative probability and then copying that down. And then we can see by the end it accounts for 100% of the data as before. So the main things to note here is firstly the difference in the structure of the probability distribution, as we briefly touched on before, and it's not very close to a normal distribution at all. You can see that by the kurtosis and skew as well being extremely far from zero in both cases, and because of that distribution not being similar to a normal distribution, we're less concerned with the standard deviation as our default risk or volatility measure for high to low returns, and instead we can concentrate on some other ways of identifying volatility with these returns. So first and foremost, the obvious one is the average high to low return. So that kind of gives you the average maximum potential of your sort of day trading this asset. So on average, the maximum return you'll get intraday trading this asset is around 1%. And obviously when we compare that to other assets, you'll see differences in the volatility. The other thing we can look at is the maximum value. So the maximum high to low, the maximum intraday move that is measured in the period that we've analysed back to 2008 is around 11%. And also it's important just to bear in mind the frequency table data in general. So, we can get a good idea here of, say, the movements of more than 4% between high and low is around 1.65% of occurrences. So around 1.65% of the time, movements from high to low to high are over 4%, that basically means. And you can go through that frequency table with that logic as well, the same with the cumulative probability. So that's all sensible to do, as well as looking at the mean and the maximum high to low returns. Before I move on to a final cross-asset assessment and some closing remarks, I'm just going to make sure that this document is saved appropriately. So I'm going to go to File, Save As, save it to the desktop with a file name of AUD USD distribution, for example. Click Save there. So that's saved now. So the whole point of the distribution of returns exercise that we've just carried out is for three major purposes. Firstly, we want to understand, get a really good, deep understanding of how an asset, or a currency in this case, behaves and the risks and opportunities that it presents. Secondly, we want to highlight the lack of day trading opportunities in currencies most of the time. So we can see that by looking at various measures, but the main ones being the average positive and average negative returns being so low. Thirdly, we want to be able to compare the risk and opportunity across currency pairs. So I'm going to show you some of that now by comparing the Aussie dollar US dollar pair to the Euro US dollar pair. So I've got a pre-made spreadsheet with the Euro US dollar data in, and its format is exactly the same as what we just went through building in the Aussie dollar US dollar pair. So for example, our average positive and average negative returns here are plus and minus 0.44%. If we go back to the Aussie dollar US dollar pair, we've got roughly plus and minus 0.58%. So the volatility there is higher, or the returns are higher. On average, both positive and negative. Equally, we could look at some other volatility measures like the standard deviation of open to open returns, which is probably the main one that we should be looking at as a volatility assessment. So with the Aussie dollar USD, that's 0.867%. When we compare that to the Euro USD, that's 0.629%. So again, the Euro seems to have lower volatility in a pair with the US dollar compared to the Aussie dollar with the US dollar in a US dollar pair. So what I've done is kind of summarized a bunch of this information that we've gone through in this video for both the Euro US dollar and the Aussie dollar US dollar. So here's some key statistics that I've picked out. Probably the most important one is the open to open return standard deviation, which is kind of the major volatility assessment that we use. Equally, we've got the average positive and negative returns, which basically show you the opportunities that lie within these currencies when you day trade them, or when you trade them over the period that you're analyzing. And I've thrown in there the range, the minimum, the maximum as well, because that also gives you an indication of how the asset that you're looking at behaves, and it's another kind of risk-reward measure there. And on the high to low returns, as we discussed just a few moments ago, the key ones I've picked out are the average high to low return and the maximum high low return in the period. So what we can see basically, the final outcome of this cross asset comparison with the Aussie dollar US dollar versus the Euro US dollar is basically that all our risk measures here are higher in the Aussie dollar US dollar pair than the Euro US dollar pair, which basically means that there's greater risk, but also hand in hand with that, greater opportunity to profit from trading the Aussie dollar US dollar pair compared to the Euro US dollar pair.
Okay, so welcome back to the computer screen. What we're going to do here is have a look at what Chris has just gone through in the context of where we've been going with the overall volatility analysis throughout the video series so far, and really put this into context so we can cement the understanding of where this is all going. So if you recall, in previous videos, we got to our definition of different currencies through both their diversity or concentration with regard to commodities prices, and also from the regime that they're exposed to. And we've now got to a point where we have this tradable set, and the tradable set is defined by 4 different definitions of currencies. And we've got our X commodity floating majors, our X commodity floating minors, our commodity floating majors, and our commodity floating minors. So the first thing to notice is obviously that every currency pair in our tradable set is a floating regime. But secondly, some are more concentrated more than others in terms of their exposure to commodities prices. And we got to this point where we drilled down almost and said, okay, if we drill down through regime, we only want to be exposed in terms of volatility to floating regimes, but also we want to understand the opportunities and risk by understanding the difference between currencies that have got very concentrated exposure to commodities, so 1 or 2 commodities prices, and currencies that have exposure to a multitude of commodities or have exposure to a much more diverse range of variables. And we started ranking these in terms of potential volatility and liquidity. And if you go to the download section, the analysis that Chris has just done with the open to open and high to low analysis with distributions, you'll be able to download all of these spreadsheets here, and you'll be able to go right across the tradable set. So you've literally got everything in the download section. What we've also got there is a distribution and ATR ranking system. We're going to be looking at ATR in video number 6. And these ranking systems basically allow you to filter the data to see currently what are the most volatile to least volatile in terms of standard deviation, and also high to low. We've also got a PDF download in the download section, which gives you a thorough breakdown of how you go through all the steps that Chris has just gone through with you. So all of these downloads here are really helpful in terms of understanding the volatility, therefore the opportunities and risk in our tradable set that we've got to. So what you really need to be doing is going into the download section, taking all these spreadsheets, the resources, and the PDF, and really starting to understand how these numbers are calculated and what they really mean. And what you're going to do by doing that by default is you're going to be understanding and appreciating where opportunities and risk actually lie in the Forex markets. So where opportunities and risk lie across currencies and also across different time periods. And by doing that as well, what you're going to do is also start to realize where opportunity and risk doesn't lie across the Forex spectrum. So which currency pairs are not volatile and don't have opportunity and have very little risk associated with them. And what you should be doing is really opening up a blank spreadsheet and practicing this method yourself. So open up a blank spreadsheet and just do this on a rinse and repeat basis and really practice it so it becomes second nature. So what we're going to do is just have a look a bit more closely and really understand and cement what's going on here. Why do we even do this in the first place? Well, we do it because primarily it gives us a base system in comparing opportunities and risk across the entire Forex spectrum. And there's two main points here to note. The first one is, you'll recall earlier in the video series when we started looking at basic calculations. The first point is that we realized that comparing pips really isn't a way in order to compare opportunities and risk. It's the way the brokers want you to think. And it's not a good way of comparing opportunities and risk because it's not a one-for-one base system. And we're not comparing like for like. So let's put it this way. It's not really comparing apples to apples. It's comparing apples to bananas. It's confusing. We have to use a base system. So we change everything to percentages and we anchor ourselves to using everything in terms of percentages when analyzing opportunities and risk, so volatility. And secondly, opportunity and risk go hand in hand. And you'll hear this a lot in the financial markets. Without risk, there's no opportunity. And with risk comes opportunity. And volatility measures both risk and opportunity. And when we compare multiple assets against each other, we discover which assets have the most risk and opportunity and which assets have the least risk and opportunity for each unit of currency that we put into a trade. So for equivalent position sizes. And we do this because we want to deploy capital efficiently and optimally. The approach overall that we take here is really the true measure of opportunity and risk, and it's the way all professional traders do it. So this is something you need to get used to. We mentioned earlier in the video series that professional traders do things at a much more higher level in terms of mathematical rigor when compared to retail traders. Well, this is exactly what we're talking about. You need to really bring yourself up the curve, and if you've got any hope of being consistently profitable in the financial markets, even in other asset classes, not just currency trading, you need to try and really bring yourself up the curve. And we've done this in a way for you that eliminates a lot of intellectual snobbery and gives you a really good shortcut into understanding how professional traders do it. Now, also, if you've got any hopes or dreams of going into the financial markets as a profession, so going to work for an investment bank or a hedge fund or an asset manager, this is the type of stuff that you're going to have to learn. Typically what will happen is this will be the type of information and training that you would get if you were on the desk at those institutions for the first 1 or 2 years. And you'd be expected to know all this after 1 or 2 years. Now, the great thing about this is you can learn it before you even go in. You know, that's the type of information we give here at the Institute. So in the labor market, when you're applying to these places for internships, graduate schemes, or just jobs in general, you're going to stand out. You're going to be leading the pack in terms of knowledge. So whether you're a retail trader who just wants to learn how to make money consistently using their own money, you know, this is stuff that you just have to get up the curve on. Or if you're somebody who wants to go into the industry, if you know this before you go in, you're going to be head and shoulders above everybody else in the application process. Okay, so let's try to understand this process. If we go through the overall situation here, what we're trying to do is take the entire tradable set and discover which time frame is going to give us the optimal opportunities. And we're going to look at the whole set also to discover which currency pairs over various time frames are the most volatile and which are the least volatile. And basically what we've done is ranked each currency pair from the most volatile to the least volatile on a distribution and ATR basis in order to look for the opportunities and the risk. Now, this is a snapshot taken as of when we have put the video series together. This is something that you need to do on a consistent basis, and depending on your own timetable, it depends how frequently you do this yourself. But it's quite important to do this to understand at any one point in time where opportunities and risk lie in the currency markets. So Chris went through a couple of examples. We looked at euro dollar and we looked at the Aussie dollar pair. And if we look at euro dollar on the open to open distribution, what we discovered was that the numbers are really not that great when we're looking at daily volatility. So, for example, in euro dollar, the mean return on a daily basis of the currency pair is 0.005%, and the median return was 0. Now, when we look at the daily volatility on average on an up day and a down day, the daily volatility on average in euro dollar on an up day is actually 0.21% from open to open. And on an average down day, it's 0.21% as well. So we can see that there's a couple of things we need to consider here. Firstly, if you're going into euro dollar with the idea that you're going to day trade it, what is likely to happen from all of the historical data and information that we can get our hands on a daily basis, the most likely thing to happen is that you're going to get a return of 0. And that's if you're basically just picking out of the air which way you're going to go. And obviously that's without paying a spread, but essentially your mean or median return, you should expect that if you're day trading, regardless of what your strategy is over one day, it doesn't really matter because you cannot argue with the numbers. The numbers are the historical numbers of the actual currency pair on a daily basis. Regardless of your strategy, you should be going in expecting to make very close to 0 on a daily basis. Now, if you go into the market of euro dollar and you're a day trader and you decide today I'm going to buy it, well, if you're actually right and the euro dollar pair does go up on the day, you can expect to make 0.21% on average. And on an average down day, 0.21%. Now, you might look at those numbers and think, well, if I leverage that 50 to 100 times, that would be a great return on a daily basis. Totally missing the point. Because, first of all, you have to pick the right direction, which is basically a coin toss. And if you leverage the return that isn't there, you could actually just be wrong and lose a lot more money. So the risk is basically as much as the opportunity, regardless of how much you leverage. Now, a 1 standard deviation move in the currency pair, which occurs 75% of times in either direction, is within the bounds of 0.595%. So basically what that's saying is, if you think of this in reverse, 25% of times, so in the vast minority of cases, you will get a move outside of that number. So we can see that if we just looked at this asset in absolute terms, the numbers are not that great. A 2 standard deviation move, which only happens 5% of times, is a move that's greater than 1.2% in either direction. The numbers aren't great. And regardless of how much leverage you throw at this asset, the asset won't move because you've borrowed more money. The historical information tells us objectively within the data that this as an asset is a very low return or low volatility asset. Okay, so that's looking at euro dollar on a daily basis and looking at the open to open and working out the distribution of returns. So a distribution analysis of the open to open. What about if we looked at the daily data and we looked at the extremes, the high to low? Well, if we look at the descriptive stats that Chris went through for euro dollar, the mean high to low return on euro dollar is 0.823%. And what we're looking at here is literally the perfect day. So what we're saying is that if you picked the right direction and you literally bought at the low and sold at the high, the maximum you could ever make is 0.823% historically. And the maximum high to low range out of the 4,430 days has been 4.22%. So we're looking at the maximum in the descriptive stats here. That's basically saying in the history of the data of euro dollar that we're looking at, the data set, the 4,430 days, that is the biggest move or range from high to low in the history of the data that we're looking at. So what we're looking at here is looking at the maximum volatility opportunities on a daily basis. And the average, the mean of 0.823% is basically the average of our perfect day. And again, if we compare this to the numbers here, we see a 1 standard deviation move 75% of times within the bounds of this region here. That's open to open. And we have 0.823% as our average perfect day. You can see now and get an appreciation and understanding of what we're dealing with here. We're dealing with extremely low opportunities and a backdrop of an industry that, in terms of conflict of interest, may want us to believe that the opportunities are far greater. Now, if you're on the other side of the leverage, so you're providing leverage and you're the broker, these are conditions that you like to see because the risk is low. If you're on the other side of leverage, these are the conditions really that you don't want to see because the opportunities are also low. So we have to look at this very objectively, and if we look at it in absolute terms, if we just covered up the name of this asset, and this was just presented to you as a potential opportunity to make money on a daily basis, if you looked at it objectively, you would probably look at it and say, well, obviously it isn't. When you compare this, so not looking in absolute terms, when you compare this asset, whose name we shall ignore for the moment, when you compare this asset to stock markets, for example, the opportunities or the volatility, opportunities and risk is far greater in stocks and stock markets. And we go through a lot of this analysis in the other video series, the Professional Trading Masterclass. So on an absolute basis, you may not think this is an opportunity. Even on a relative basis to other asset classes, the volatility is extremely low. So does that mean Forex trading is defunct? Does that mean we shouldn't bother? Not at all, because we can further our analysis and look within the Forex complex and discover where the opportunities and risk actually lies, where we can actually capture volatility. So if we actually compare currency pairs against each other and rank them, we can figure out what our best approach might be. So we looked at the Aussie dollar US dollar in the same analysis, so daily volatility open to open and daily volatility high to low. And we found that the mean return in Aussie dollar US dollar is also pretty low, with a median return of 0 or close to 0 also. The daily volatility on the average up day, so if we actually decided to buy and we got it right on a daily basis, we called the direction correct. The daily volatility was higher than euro dollar at 0.29% and the same on an average down day. Now the one standard deviation move, so 80% of times in either direction, is within the bounds of 0.887%, which means in the vast minority of cases, again, so 20% of times we get a move in either direction that's greater. The two standard deviation move, so 5% of times, is a move greater than 1.8%. So we can see here when we compare Aussie dollar to euro dollar, the numbers in terms of mean and median are very similar on a daily basis. And daily volatility, if we pick the right direction up or down, and we're right, we can capture 0.29%, which is still very, very low, but it's higher than euro dollar. So there is some sort of comparison conclusion to draw from that. Now, if we look at the high to low, we can see that the mean high to low return, we discovered that Aussie dollar cross is actually greater in terms of high to low magnitude on average. And that comes in at 1.165% when compared to euro dollar at around 0.8%. So we can now also see that not just from an open to open analysis in terms of distribution, but also on a high to low return, that the volatility on the perfect day in Aussie dollar, the magnitude is higher. The maximum high to low range in Aussie dollar out of the 4,430 days is 10.89%, so around 11%. So there has been a situation in the past, obviously very rare, where Aussie dollar has had a high to low range of 11% in one day. So we're dealing with a slightly different beast here. We're dealing with a currency pair that actually moves more than the currency pair that we looked at before. And that's if we call the right direction on a daily basis, also on a standard deviation basis, and also on a high to low return. And in the rare examples of our maximum, we get much greater magnitude moves. We can look at these things as possibly shocks in the market. But overall, the lesson to learn here is that Aussie dollar, US dollar has greater exposure, greater volatility, because they have greater exposure to one or two commodities when compared to a cross like euro dollar that has less volatility and a much diverse exposure to multiple variables. And we're going to go into this conclusion much later, but that's what we need to draw at the moment, and take a lesson that over this particular time period that we're looking at, we're starting to get clues as to which currency pairs over this particular time period are going to be more volatile, or given all the evidence are actually more volatile historically, and also getting clues as to why that might be, due to our overall tradable set and our definitions. However, the overall conclusion is that when we look at these things on an absolute basis, over this time frame, there isn't much volatility. On a one-day basis, in either of these currency pairs, the opportunity to make money is extremely low, but the risk to make or lose money is extremely low as well, because they're one and the same thing. Opportunity and risk are one and the same thing. So we have to bear that in mind. So let's just conclude all of this here in terms of looking at distributions. We can obviously see that on the daily basis, Aussie dollar is more volatile than euro dollar. But it doesn't mean that we should be looking to day trade Aussie dollar as a preference or a trading strategy. The daily volatility in euro dollar is 21 basis points or 0.21%, and Aussie dollar 29 basis points or 0.29%. And that's on the condition that you pick the correct way. So you actually get it right. If you don't get it right, you're very likely just to make nothing or lose that amount. So there's very little room for error if your strategy is to simply day trade day after day after day after day. On a high to low basis, the average day in Aussie dollar is almost twice the magnitude in percentage terms than euro dollar. But do bear in mind that in either case, regardless, you would literally have to buy the low print of the day and sell at the high print of the day. So the perfect trade every single day to achieve these returns, which is obviously completely impossible. What we're doing here is academically going through it to get a sense of and to show you how bad the actual risk reward is. Also, overall, so we're looking at this now in absolute terms, euro dollar and Aussie dollar, in both currency pairs, the up and the down days are the same. It's literally a coin toss. And these are the real numbers historically, so nothing can change them. Regardless of what you call your trading strategy on a one-day basis, whether you're looking at 5-minute windows, 1 hour charts, 4-hour charts, you're looking at stochastics, you're looking at various technical analysis over 1 hour, 4 hours, 8 hours, a 5-minute candle chart with multiple lines crossing each other, signaling day trading opportunities. It literally does not matter what you think your strategy is. These are the numbers, and unfortunately, they can't change. So when you're looking at these numbers, the data will dictate over many cases in the present, the past, and potentially the future. So give you an extremely good idea of what to expect in your returns. The data should be sending you a very strong message. The message is quite straightforward. We have to seek to increase our time horizon so we can capture larger volatility and actually capture fundamental trend. Day trading currencies in a very highly leveraged manner or highly leveraged trading account is something that dummies do in terms of their approach, as in the dumb money. The dumb money that brokers and smart money preys on, because on the other side of your trade is somebody who is either lending you money to leverage the returns that don't exist and charging you for it, and doing that because they have very little risk in doing so, and actually they have a 90% win ratio. Or it's the smart money who are trading on larger time frames and trading on fundamental trend and using the liquidity that you provide them on the one-day time frame to get out of trades or get into trades when they see the opportunity moving forward. So what we're witnessing here now overall is the answer to all the questions, which is, what is the opportunity? in Forex pairs on an absolute basis? Well, on a daily basis, we've learned on an open to open and high to low basis, in absolute terms, that the opportunities are very little. Combine this with an understanding of infrastructure and conflict of interest, and also how smart money approaches the market, we're beginning to really understand now why 90% of retail traders in the Forex market lose money, and lose most of their money within a very short space of time. Okay, so before we really start to look at changing our approach and looking at longer term time horizons, let's look at this on a relative basis. So we need to look at this overall on an absolute basis and on a relative basis, in that we compare across the Forex complex and our tradable set. We compare the currency pair volatility to each other. So if we look at the table on the left hand side here, what we have is all of our currencies in the tradable set, and we have our measures of standard deviation and distribution on a mean high to low basis. And what we've done here is we've ranked in terms of standard deviation. You can also rank, if you want to in your own time, from the download section. You can rank on a mean high to low basis if you want to, but here we've looked at the standard deviation. And where do the opportunities actually lie, and where do the opportunities actually not lie? Well, let's have a look at euro dollar first, and we can see that euro dollar is actually almost right at the bottom of our opportunity set. So on a relative basis, euro dollar is not very volatile when compared to all other currency pairs. And you need to look at this also on an absolute basis, as we did earlier. What you're actually doing here, if you decide, okay, on a daily basis, I'm going to trade euro dollar, therefore my trading strategy is to day trade it every single day, day after day, and pretend to have a strategy. By all historical measures of data, on daily data, on standard deviation, it's a fool's game, because on an absolute basis, you're trading a non-volatile asset, and that's non-volatile regardless of anything. And on a relative basis, within the asset class that isn't very volatile, you're trading one of the least volatile pairs. So actually, day trading euro dollar, and even the currency pairs like sterling US dollar and sterling euro, which are even lower, day trading these types of currency pairs, thinking that you've got a trading strategy, day trading them is one of the stupidest things you'll ever do in trading. Obviously, because you're in a non-volatile asset class on an absolute basis, and you're trading on a relative basis the least volatile pairs. It's no wonder that 90% of Forex day traders lose money. It just simply means that there's no opportunity for Forex day traders, and no risk for the brokers who are on the other side giving you the leverage to deploy this strategy. So it's pretty obvious when you look at this in an overall perspective of how retail Forex markets work. It's no real surprise that all the marketing and advertising of retail Forex brokers tries to push everybody to trade these types of currency pairs. What you actually have to do is try and do the opposite, increase your time horizon, look for fundamental trends like professional traders and hedge fund managers. Now, what we're going to do here, we looked at Aussie dollar, US dollar, and this is pretty interesting because it's one of the highest one standard deviation, so normal daily moves historically against the US dollar. So when we're only looking at US dollar crosses, the only ones that are more volatile are the dollar ruble and the dollar South African rand. And funnily enough, they're also commodity currencies. We'll come on to this a little bit later. But now what we're going to do is move on to another method of how to calculate distributions. and this can be used for weekly and monthly data too. So both methods, both distributions and ATR, which is what we're going to move on to now, can be used for daily, weekly and monthly data. So we're going to look at this other method to demonstrate weekly and monthly data, but do bear in mind that in your own time you can actually go through this exercise again, the distributions exercise for weekly and monthly data. But we're going to look at Aussie dollar, US dollar further and use this method to calculate weekly and monthly data, because Aussie dollar is becoming interesting to us in terms of volatility, but also it's to demonstrate another method of doing it using weekly and monthly data. This next method, the ATR, is a lot simpler way of doing things, and we can actually compare the ATR results with the distributions results. And what we're going to find is that they're quite similar. So one of the things you can take away from this is that the professional approach of calculating volatility using statistical and distribution analysis, you'll find that there's quite a lot of intellectual snobbery in the financial markets. We're about to demonstrate to you that if you calculate things quite simply, you can get to very similar answers and conclusions. So that's one thing to take away. But Aussie dollar, US dollar on an absolute basis with euro dollar, day trading clearly is not a great strategy across the Forex complex. It's pretty obvious when we look at that in absolute terms what we need to do. In absolute terms, we need to actually just increase our time horizon, begin to look at weekly and monthly data to see if we can capture volatility further. But also on a relative basis, our daily data has given us a clue as to what to expect from our bigger timeframes in terms of the volatility of currency pairs compared to each other. So Aussie dollar, US dollar against Euro US dollar is clearly more volatile on a daily basis. That's giving us a clue as to what is most likely to be the case in weekly and monthly data. So let's go back over to the trading desk for a recap, and then we shall move on to video number 6. Okay, so welcome back to the desk. Just to recap everything that we've seen there, what you saw when Chris was going through this process of analyzing the data and calculating the distributions of returns, what you saw was actually a very similar way in which professional traders go about calculating distributions. In fact, it's almost exactly the same. And the reason why professional traders go about it like this is because this type of method is transferable across many, many different sets of data. Now, in the bigger picture, what we've learned as we've been going through the foundation is that we obviously need this base measure of volatility. And we need this base measure of volatility because we need to ascertain through calculations where we need to be concentrating our efforts and optimally deploying our capital, both on an absolute basis and on a relative basis. So professional traders do this right across all asset classes. So in stock markets, in currency markets, in commodity markets, in bond markets, and within each market comparing the individual assets against each other. So for example, in stock markets, there's 42,000 stocks in the world. And we might want to know about stocks in the United States versus stocks in Europe. We might want to know about how oil stocks compare to auto stocks. And in the currency markets, we do this in a slightly more plain vanilla way. We look at currency pairs against each other within our tradable universe. And so we do this on an absolute basis for currencies against all asset classes, and we do it for currencies against each other. And what we've discovered as we've gone through the foundation is that after requiring having a base metric to measure all volatility, both in absolute and relative terms, when we do it specifically in the currency markets, on an absolute basis, on a daily basis, the returns are not actually that great. And it tells us as professional traders that what we need to be doing is taking a different approach. What we also learn from the daily data is that there's actually quite a big difference in terms of volatility when comparing them. So we looked at the examples euro dollar and Aussie dollar in particular, and we saw that on a daily basis, even though taking the day trading approach is in an absolute sense not the right way to go, as evidenced by the data, we found that Aussie dollar is a lot more volatile than euro dollar, which obviously, when we change our approach, gives us some clues as to what's going to happen when we start looking at bigger timeframes, weekly and monthly data. So we do learn a lot from these numbers, and the professional trading approach of looking at it in everything in absolute and within each asset class relative to each other, the professional trading approach can also apply in terms of not just opportunities, but in terms of risk. And what you'll find is when you go on investment bank trading floors and also into hedge funds, what you're going to find is a lot of their risk models are dependent on volatility calculations. So when they build portfolios, their risk models are built literally to tell them what the risk of their portfolio is on different timeframes. So how much they can lose in 1 week, how much they can lose in 1 month, and even how much they can lose in 1 day, based on the historical analysis of the volatility of all the assets in the portfolio. And this is why it's so important to bring yourself up the curve to understand this stuff, because there's only 2 objectives really from the retail trader. Either 1, you're looking to use your own money to make money consistently in the financial markets, or 2, you're looking to do that and then turn it into a profession. Either way, you've got to get up the curve and start to understand this stuff. But if you in particular are looking to go into the industry, this is the type of stuff that you really have to understand. Now, if you're not looking to go into the industry, that's fine, but do bear in mind that this is really crucial stuff to try and understand. It's not absolutely 100% essential, but there's no downside in you learning this. Learn it, occasionally take data on a daily, weekly and monthly basis on all your currency pairs, and in the download section we've provided you with all the spreadsheets. Take the data and go through this exercise. Try to do it regularly to see what's happening with the numbers. And what you'll find, if your objective is to go into the industry, is that when you go in, there might be a lot of intellectual snobbery around stuff like this. That's nothing to worry about, because if you learn this before, you'll know the approach when you go in. And when you go into investment banks and hedge funds, what you'll find is that they go into a bit more depth, but it's essentially the same stuff. Now, what we're going to move on to is in video number 6, we're going to look at a lot more simpler approach to volatility and to calculating volatility, called the average true range. And the ATR is a bit more cruder, so depending on your objective and your own timetable, you can take both approaches, or you can take one of the approaches. And if you take both approaches, it becomes a good head check. So one approach against another. So if you use one approach, get to a certain result, use another to check it, and you get a broader appreciation of understanding. You can do either. You can use both, or you can use one. If you are short of time, what you'll find is that if you use the average true range, the average true range does get to answers very close to the statistical distribution analysis anyway. So there's no harm in doing both of them, but if you really are short on time, use the ATR and you'll be fairly close anyway. Okay, so in overall terms, we've built up this foundation now. We've been through all of the infrastructure, all of the opportunity set. We've been through basic computational methods and regimes. We've got to a point now where we really thoroughly understand how Forex markets work, and we've even moved on to more advanced computational methods. So now we're going to move on to video number 6 with ATR, and that will conclude everything in our overall foundation of understanding Forex markets.